Tape 2. Introduction to Area Drainage System, J. Paul Guyer, PERA. Tape 2. We're on part 3. This is part 2. We're on chapter 3. Alright, in-place inlets are given the optimum arrangement of the flow interception for the following guides apply. Any street with an intersection crosswire inlets, usually with a plate for the upstream of the guide of the transport flow across the street and the roadways will be not used. Intermediate point of grades and the greatest efficiency economically commonly resolve with either graded or curb inlet design intercept only with about 3/4 of flow. And sag vertical curve of the 3 inlet often desirable at one low point, one on each side of the low point with the gutter grade is about 0.2 feet above the low point. So its layout effectively reduces the pond buildup or deposition sediment in low area. Large quantities of surface runoff flowing toward main thoroughfares normally share with the intercept before receiving them. At a bridge curbed approach for the gutter flow should be intercepted before reach of the bridge, particularly when the freezing weather occurs. Where a road pavement that continues grade with a warp transition between super elevated normal surface section, the surface of the water should be normally with the intercepted upstream of the point where pavement cross slopes begin to chain with a special area where icing occurs on roads where curbs are used to run off of the cut of slopes from off-site areas with where impossible to intercept with the ditch at the top of the slopes. Swills along shoulder not allowed with the flow on the roadway. This is practice minimizes the amount of water intercept the gutter inlet helps to prevent mud debris from being carried to the pavement. Inlets placed in sumps have greater potential capacity inlets onto the slope to cover the possible submerge within some capacity for the graded with the curve of the combination inlet sump will be computed with the outline below to allow the blockage traffic the side of the inlet opening select with the construction will be increased with above the computed size of the 100% of the graded inlets, 25 to 75% depending on the draft conditions. Curb inlets, combination inlets, graded type and sump with depths of up to 0.4 feet over the wears falling with Q is equal to 3.0 times L to the 8 times H 3 to the third exponent of 3 seconds. One side of the rectangular grade is akin to the curve, one side of the admitted with the computing of the parameter of the depth of the water above 1.4, or if it's foul, the Q is equal to 0.6 times A times 2 to GH to the 1 to the 1 half. For the depth of 0.4 to 1.4, operation indefinite due to the voracity and other disturbances. Capacities will be somewhere between those given in the preceding formulas. Problems involved with the above criteria may be solved graphically using a figure. Curb in type and sump. The curb inlet sump of the above listed general concept of the wears orifices flow apply lateral being in effect with the depth greater than about 1.4 H of the H of the height of the curb opening inch of the figure 3-4 presented with the graphic method of estimating capacity. Combination type and sum of the combination inlet sum with no specifically formulas given the sum of the increase of the capacity over the provided singly by either graded open and curb opening that may be expected. The curb opening will operate with the leaf opening with the grate becomes clogged and debris estimated with the capacity inlet tree with a simple graded inlet but safety factor 25 to 75% will be applied. Slotted drain type, slotted drain inlet in a sump. The flow will enter with the slot either with the orifice all orifice type or all weir type depending on the depth of the water over the edge of the slot. If the depth is less than 18 feet, length slot will require to intercept the total flow is equal to Q divided by 3.125 times D to the third divided by 2. Depth is greater than 0.18 feet with the length of the slot required with the intercepting total flow will equal to Q is equal to 0.5 times W times 2 GD to the 1 half. Depth of flow, D is equal to depth of flow in inches, W is equal to wide slot of 0.146 feet. Each of the series of the inlets placed on the slope is usually optimum efficiency design. The intercept is somewhat less than the design gutter flow, with the remainder being path with downstream inlets. The amount that must be intercepted is governed by whatever the width of the depth of the pass flow by can be tolerated from traffic safety viewpoint. So this toleration level will nearly always be the influence of cost drain of construction. Flat street crowns prevently modern construction. Mainly gutter flows are relatively wide built up areas, so the inconveniences are inevitable, especially for the region with high rainfall. Less elaborate inlet system is provided with achievement of the satisfactory system reasonable cost requirement of the careful consideration use factors, careful design inlet themselves However, it must be also remembered that the limitation type of the Sabbath given the project also desirable for standardization will be the lower construction cost of the design with the graded curved combination inlets. Slopes will be based on principles outlined below. And it shows a capacity graded inlet sub water pond on a grate. And this shows a picture of a capacity curb outlet, opening inlet load point drainage. Alright, your graded type of slope on slope graded inlet placed on the sloping gutter with the provide optimum interception flow with the bar with the place parallel with the direction flow openings total with the less at least 50% of the width of the grate with a normal to the direction flow, and unobstructed opening is long enough to parallel with the direction of the flow. The water flowing the clear of the downstream end of the opening of the minimum length clear opening required depends on the depth, velocity, flow, approach of the gutter, thickness of the grate end of the slab with the minimum length with maybe the estimated partial empirical flow. Formula L is equal to V divided by 2 times Y plus D to the 1/2, exponent 1/2. Rectangular grade and gutter with a continuous grade with expect with the intercept of the water flowing with the part over the gutter across the section with the occupied with a grading plus. Mount will flow along with the exposed side with the height over the left of the grate is over 3 feet long with a greatly depressed, extremely warping the pavement is seldom impermissible. While water flowing outside of the grate, you can serve with the bypass of the inlet with the quantity flow with the preservation intercept with the surface of the grate can be computed with the following instruction. 3 in figure 3.2 with the from along grate with the flow along the side can be estimated considering edge of the grate as a curb opening whose effective length of the total grate length with an ignoring crossbar reduced by the length of the jet directly intercept the upstream end of the grate and to attain optimum capacity inlet consisting of the 2 grates separated with a short length of the paved gutter, and the grate should be spaced between the carryover the upstream grate will move sufficiently toward the curb and intercept the downstream grate. Alright, curb type on the slope. General with the curb inlet placed on the grade with a hydraulically inefficient structure of the flow interception. The relatively long opening required completely interception because of the heads of the normally low with the direction oncoming flows is non-favorable. The cost of the long curb inlet must be weighed against the drop type of the potential costly grate. The capacity of the curb inlet with intercepting the flow can be calculated by an empirical question. The equation is the function of the length of the clear opening with the inlet depth of the depression flow line, inlet and feet with the depth of the flow and the approaching gutter and feet. Depression of the inlet flow line is essential part of the good design. Curb inlet, no depression, and very efficient. Flow interpreted may be marked increase with the change in the opening length of the flow line with it be depressed by 1 time with the depth of the flow and approaching gutter with the use of the long curb openings. Intermediate support should be generally avoided because of the tendency for the support of the accumulated trash. If the support is essential, they should be set back several inches with the gutter line. Combination type on slope. The capacity for the combination inlet and with a continuous grade with the not much greater than that of the graded portion itself should become separated graded inlet except with the following situation with the curb opening place with the upstream of the grate with a combination inlet with the consider with the operate with the 2 separate inlet with the capacity that can be commuted accordingly, so with the arrangement and sometimes with the desirable addition with the increase of the capacity of the curb opening with the time with the intercept of the debris, thereby reducing clogging with the grate. If the curb opening placed downstream of the grate with the effective operation with the 2 separate inlet required with the curb opening efficient downstream, allow flow bypass of the grate and move with the curb opening. The minimum separation will vary both with the current slope of the longitudinal slope. Structural aspect of the inlet construction should be generally indicated with the figure 3.5, 3.6, 3.7 that show the respectively standard graded circular grate and inlet type A and B with the triangular rectangular grate with a combination inlet with the type C with the curved inlet type D. It will be noted that the type D provided with the extension of the opening given by addition with the collecting with those with the back wall with the cantilever with the curved face, availability with the grading and standards of municipality and given the reach of the maybe limited the choice of the inlet type with the graded inlet subject with the heavy the wheel load with the required graders precast steel but built with the upper weld steel with a steel grade with a galvanized bituminous coat with the unusual inlet conditions require special design. Alright, these show the standard type A and B inlets, standard type C square grading, standard type D inlet. Are vehicular safe and hydraulic efficient drainage practice. Some drainage structures are potentially located with the path of the ramp with the vehicle can substantially increase the probability accident inlets should be flushed with the ground should be with non-obstacle with the vehicle that is out of control and the structure of the culvert should be placed outside designated recovery area wherever possible the grade is necessary with the culvert. Any care with the care must be taken with the design of the grate inlet with the neck line during the period of high water. The curb inlet system step back should be minimal grades, so it should be designed with a hydraulic efficiency safe passage of vehicles. Header's channel with the injury dissipating devices should be located outside of the designated recovery. Adequate guardrail protection should be provided. It is necessary to emphasize that the liberty should not be taken with a hydraulic design drainage structure to make them safer and lift it clearly that function and efficiency will not be impaired with the complicated changes, even in the mere minor change of the culvert inlet series to disrupt the hydraulic performance. Alright, 4. Erosion control, riprap protection, general hydraulic structures. The discharge opening channel will provide with the riprap protection, prevent erosion to general type of the channel. The instability can develop with the downstream with a culvert or storm drain outlet with conditions is known with either gully score or the localized erosion referred to as the score hole. The distinction between the two conditions, score prediction with the type of the anticipated with a given field of the situation can be made by a comparison of original existing slope of the channel with the drainage basin downstream outlet relatively required stability. Your gully score is expected with a broad number of the flow with the channel exceed with the required stability and begin with the downstream wherever the channel is stable to progress is upstream and the insufficient differential of the elevation exists for the outlet with the section stable of the channel. Outlet structure will be completely undermined with erosion type with the may be considered extent with it depending upon the location stable channel section relatively outlet both of the vertical downstream direction. Score hole. Localized erosion expected with the downstream outlet with even if the downstream channel was stable with the severity of the damage for the anticipated depending on the conditions existing created with an outlet. In some instances, the extent of the score hole may be sufficient to produce either instability with the embankment structural damage. The outlet, however, the many situation flow with the condition with the produce the score to the extent of the embankment erosion as well as structural damage, apron, end wall, and culvert are evident. Empirical equations have been developed that estimating the extent of the anticipated score hole has been knowledge of the design discharge culvert diameter, duration, fraud number of the design flow with the culvert outlet. Riprap protection. Our riprap protection should be provided with adjacent to the hydraulic structure of the plate with the corrosive material with the prevent score with the end structure of the protection will cover the bed and bank for the sufficient distance, established velocity of the gradients, turbulence level, and riprap approximation condition in its natural channel. The riprap can also be used with the lining channel banks to prevent lateral erosion, undesirable meandering. Consideration should be given the providing expansion either in both the horizontal and vertical direction immediately downstream with the hydraulic structure of the drop structure, energy dissipator, culvert outlets, other devices that flow expand with the dissipate and except for the energy with the turbulence rather than the direct attack with the channel both sides. There are 3 ways. Riprap has known with a fail fall and known to fail movement of the individual stones combination velocity with the turbulence movement of the natural bed material through the riprap resulting in slump over the blanket and undercutting level of the riprap score at the end of the blanket. Therein, design consideration must be given to a selection of adequate size stone, use of the adequate graded riprap provision, filter blanket, proper treatment, and end of the riprap blanket. Selection of stone side of the curve available to selection of the stone side with the protection funded, but the fraud number 2 curve is available to one use with the riprap subject with the direct attack adjacent hydraulic structure for the side inlets confluence and energy dissipated where turbulence levels are high, or the riprap bank straight channel where flow with the relatively quiet and parallel to the banks. Depth of the flow, average velocity channel known with the fraud number to be used in stone side of the determined appropriate curve of the curve to determine with the riprap side of the curve to prevent score downstream. Culvert outlets with a score hole for the various depths are also available. The thickness of the riprap blanket should be equal to the longest dimension maximal size stone, or 1.5 times the stone diameter, 50% with whichever the greater, usually large rock, of the desirable, the impractical substitution routed reach of the smaller rock and area with the high velocity turbulence may be the appropriate grouted riprap should be followed with undergrouted reach. Our riprap degradation, well-graded mixture with the stone side with the preferred with the relatively uniform side with the riprap. Certain location available material may dictate the degradation. Riprap to use in some cases the degradation should resemble the cloth with resemble the recommended mixture. Consideration should be given the increase the thickness of the riprap local blanket. Local dictates the use of the gradation large percent of the small stone. Then riprap with the gradation available, the riprap stuff with the movement of the natural material with the riprap blanket would be likely filter blanket of sand, crushed rock, gravel, or synthetic or cloth that must be used under the riprap. Unusual blanket thickness is 6 inches, but greater thickness is sometimes necessary. Riprap design. An ideal riprap design will provide gradual reduction of ripraps of the size of the downstream of the blanket's bed with the natural bed of the material is seldom justified. However, the unlifted turbulence caused by the riprap is likely to develop a score hole at the end of the riprap blanket. Suggestion of the thickness of the riprap blanket doubles in the downstream and end of the protect again for the undercutting unraveling. Alternative is to provide constant thickness for the rubble, the blanket, suitable length with a dipping below with a natural stream bed to estimated depth of the bottom score. 5. Subsurface drainage general. The water beneath the ground surface is defined subsurface. The free source of water. Free source is the free surface over the water surface, only which the only atmospheric pressure acts, called the groundwater table. The water contained above the impermeable stratum held, hence infiltration water prevented the reach of the groundwater table at the lower elevation. Upper body water is called the perched groundwater and is free with the surface of the perched water table. Water inlet infiltrators into the soil of the subsurface, such as the lake with rivers, rainfall, some of the portion eventually reach for the groundwater table. The groundwater table rises and falls depending on the bond relation between the infiltration, absorption, and evaporation. Groundwater flows, seasonal fluctuations are normal because of the different amount of precipitation may be relatively large in some localities. Prolonged drought with wet periods will cause a large fluctuation in groundwater level. Alright, subsurface drainage requirement determination, subsurface soil property for the water condition, prerequisite for satisfactory design, subsurface drainage system, field exploration, borings made with a connection project design should include the following investigation pertaining to subsurface drainage, the topographical command for the proposed area for the surrounding vicinity should be the period indicating all stream of the ditch as well for the natural reservoir, analyzing aerial photographies. Photograph of the selected with the construction many furnished for the valuable information general soil, groundwater condition, aerial photography, photograph presented the graphic record extent and the boundary surface of feature of the soil with the plant occurring the surface of water, presence of the vegetation slopes, valley, colorless mountain, sandy plain with the charming patterns of the drainage pattern, gullies, eroded lands, evidence of work of the man revealed in data for the aerial photographs. The use of the aerial photographs may supplement both of the detail and the knowledge of the game. With the topographical survey with the ground exploration, the sample of the exploratory work may be way more rapidly effectively analyzing an aerial photograph that have developed the general soil features, location, depth of the permanent and perched groundwater table that may be surface shallow to influence the design. See from the year rain fall cycle measurable effect of the depth of the water table in many locations. Information will be obtained from the rest of the surrounding area of the group regarding behavior, wells, springs, or other evidence for the subsurface water. Soil properties investigated with the other perfect connection for the design will supply information can be used to design the drainage system necessary to supplement these exploration location. Subsurface drainage structures area where soil information is incomplete for the design drainage system. Alright, laboratory test. Design subsurface drainage structure required with the knowledge of the following soil property principles. Soil within corner of strength with the compressibility, swell with the dispersed characteristics suitable with compact and unit dry weights and efficient permeability. And 2. Contact specific gravity, grain size of distribution, effective void ratio of the soil properties may be satisfactory depending on experienced soil techniques through laboratory test. The final selected soil prior to the design properties expressed with the range one extreme of the representative of the maximum value, but the other minimum value. The true value should be between two extremes may approach equal one or the other depending upon the variation of soil stratum. Flow of the water through soil. Flow of the water through soil is expressed with the Darcy's empirical law with the shape of the velocity flow directly proportional to hydraulic gradient. Flow is expressed in equation form as V equals K times I, or Q is V times A times K time equals K times I times A. One is Darcy's law of the velocity of the flow quantity of the discharge through the porous medium with a directly proportional hydraulic gradient. Flow must be in a linear regime condition to be true, including limitation, typical value of the permeable factors, effect of the permeable, effect of the pure fluid, temperature of the void ratio, average grain size, structural stratification, formation, discontinuities in trapped air in the water void, degree of saturation, fine soils fraction, depending on the scope of the course, but is available the pressure of the literature. Drainage of water from the soil. The quantity of water removed with the drain will vary depending on the type of the soil of the location. Drainage respect with the groundwater table. All water contained with the given specimen cannot be removed with a gravity flow sense. Water retained on thin films adhering to the soil particle with the help of the voids of the capillary will not be drawn. Consequently, determined with the volume of the water can be removed with the soil with a given type. Effective porosity as well with the permeable must be known. Effective porosity is defined with the ratio of volume of the voids that can be drained under gravity flow with the total volume of the soil. Limited effect with the porosity data with the well-graded base coarse materials. This is bank, run, sand, gravel to indicate the value of the effective porosity no more than 0.15. Unfortunately, graded soil, such as the medium coarse sands, may have the effective porosity no more than 0.25. back surface and subsurface drains. Placing a backfill in the trenches around the drainage pipe should serve the dual purpose that must prevent the movement of the particle of the soil to be drained. It must preserve these enough to allow free water to enter the pipe. The clogging of the fine particle soil minerals selected and backfills called filter material. The empirical criterion design of filter material was proposed by Terazahi, substantiated by tests on protective filter of the construction of earth dams. Criterion of filter pipe perforation to keep protected soil particles from entering filter pipes significantly is based on backfill particle size. Then it goes into the quiz for the introduction of the area drain system. Introduction to area drain system. This was part 2, tape part 2.